Hi everyone. So welcome to Suffer Placement. So in this video, I will discuss how can we write the Verilog code of any digital block. Okay. So what should be your the procedure? Suppose you are going to design the mux. Okay. Suppose I am giving one example. Suppose you are going to design the multiplexer. Okay, and the 2 cross 1 multiplexer. So what should be your the procedure? How can you write the Verilog code of this mux? Okay, so first of all, you should think. I mean, what the digital block you are going to design. Okay, you know already the functionality and the behavior of the 2 cross 1 marks. That is the two input. That is I0 and I1, and one of the selection line. If selection line value is 0, then I0 will be passed at the output. If the selection line is 1, then I1 will be passed at the output. Okay, this is the functionality and behavior of marks. This thing you should know already, then you can write the Verilog code. Okay, so that's why I already explained. If you know the basic of the digital design, digital electronics, then there is a little bit help, and you can write the Verilog code. Okay, so just from this video I am going to explain the syntax of Verilog code, how it will look like. Okay, before the going on it, I am discussing firstly the module. About module, every Verilog code will start from the module keyword. Okay, just like a the C language. If you have an idea of the C language, in C language the execution of all the program will start from the main function. Will start from the main function. Okay, and this is the curly bracket. Okay, if you know about the C language, the C program code executed from the main functions. Okay, so just like, because of that, I already explained the Verilog code. I mean, Verilog syntax is just similar to the C language syntax. It based on the C language, not completely, but based on the C language. Okay, so every Verilog code will start from the module keyword, and inside them you will write the sum statement. Okay, later we will know, and the finish with the keyword with end module. Okay, so that thing will happen always. So every Verilog code will start from the module and finish with the end module. Inside them we will write the statement, and here also we will write the module name. So that should be a variable, and it should be a meaningful. Okay, I think module name, then a small, I mean the parenthesis. Okay, and the every keyword must be in the lowercase. Every keyword must be in the lowercase. In upcoming video we'll explain what are the meaning of the keyword are those word the meaning of the Verilog compiler know already. Okay, so all the keyword must be in the lowercase. There are so many keyword is there. Like, no need to remember everything. Will automatically will be remember. Okay, like if, else, for loop, while loop, forever loop, repeat, like that. There are so many case statement. So many keyword is there. Okay, and fourth point. Okay, see, every Verilog code will start from the module and finish with the end module. Okay, and then you should write the module name. Okay, so one module, I mean fourth line is important. One module definition cannot contain the definition of other module, but we can instantiate one module in the top module. Okay, what are the meaning of that? Okay, see, I will explain later also, but meanwhile something I am explaining. Suppose here you are going to design the 2 cross 1 mux, like this is the mux. Okay, I mean module name, I wrote the 2 cross 1 mux. Just forget about write syntax. Okay, so this is the module, and you are writing the Verilog code for the 2 cross 1 mux. But if you define any module inside this module, like module half header, anything module, yeah, end gate inside the module you are defining, then it is wrong. So this is the wrong way. So inside the module you cannot define the other module. So there is any process. Yeah, is there any approach that thing you can do? Yeah, one approach is there. You can instantiate one module to another module, means to the top module of C. I mean, suppose later syntax I will explain. So, I mean, suppose in the top you have a half header. Sorry, I mean full header. Okay. So you have a full header, and you want to design this full header with the help of the half header. So you already know. So while designing a full header, we need two half header and one OR gate. So this is the I mean half header 0 and half header 1. So that is the two half header. So if you write the Verilog code of the module, so module, the full header, that is the module name, it should be meaningful. Right now I'm not writing the code, and so like that if you write the statement inside them and this finish with the end module, okay, then if you want, so the I mean full header is the top module and H0 and H1 is the half header. So inside the module you need to instantiate this thing. So if you define here the module half header, then it is wrong. Okay. So then it is wrong. So how can you do? Is there any process? Yeah, the process. Instead of them, you can instantiate one module in the top module of C. Just you should write the module. You need to define in the same directory the half header. In other module, in other the file module and half header. Half header, just I am telling, just what I want to say here, just understand this thing. So I define here the half header, okay, and end module. So now inside this module we can instantiate this half header. Just you should remember this is the module name, the half header. So how can we instantiate? This is the half header. Just by the help of the module name we will instantiate and name h0, and inside them we will write the syntax. What are the syntax? We'll discuss later in upcoming video. If I discuss right now, then it will be very the difficult. Because of that, right now this is the starting part. Right now I am starting the very low, that's why. Okay. So that, so one module definition cannot contain the definition of other module. We cannot define the other module, but instead of them you can instantiate the one module. Okay, I hope you understand this point. If you want to ask me to give one example, yeah, I can give also one example, just like the C language. If you know the C language, yeah. So if you know C language, suppose if you are defining the any function, suppose this is the f is the function, okay, and inside the functions, and inside the function you call the two function h and g. You know already now. If you have an idea of the C, then so you cannot define the function inside the other function, okay, but you can call them. So suppose this is the C language code, and in C language we define we call h function and g function. But where is the definition of the h function and g function? So the h function definition is there. Some code here I wrote the h function and the g function also. Okay, so when it will execute, just I want to say one point. Uh, uh, so control will go on the X, and then it will call, then it will the transfer to there, and this statement will execute it, and then it will be returned back. Okay, then the G function will be called, and here the definition of the G function is there. Then the control will transfer to the G, then this code will be executed and the control will the return back this way. Okay. So here the size of the program does not increases, means just it is calling and execute this block, and the control will the return automatically to the main functions. Okay. So size of the program will not increase. Okay. But so this is the similar, but in the Verilog it will it will differ. How? See, yeah, suppose if you have any top module, okay, and inside the top module you instantiate the three module M1, M2 and M1. Okay, this is the module M1 and M2. But the definition of module M1 and M2, I mean, should be there anywhere. So here I am defining the module 1. Okay, and here, so the definition of the module. So here it will start from firstly the M1 module will so M1 module here the M1 module is calling. So the control will transfer to the M1, and this code will this code will executed. After that the control will transfer here. Okay, but the one copy of M1 will be inserted, will be embedded in the top module. So this is the difference M1, and here the M2 will be called. Then the control will transfer to the M2. Then inside the M2 there is a statement, and this complete module will be embedded in the top module M2. Okay, I hope you understand. Then the M1 is again, so M1 again it will be called, and the code will be executed, and it will embedded in the top module. So here is the M1. Okay. So M1 called two times and M2 is only one time. So the three copy embedded in the top module. So this way the size of program increases. So this is the difference. Size of the overall program increases. Overall size of overall. So because of that size of overall program, you can write program increases. Will increase. So in the C language, the size of overall program will not increases, means the same. Because of that, here just calling and executing. But in case of the Verilog, when we call the any module, the copy of this module will be inserted, will be embedded in the top module, and this way the size of overall program will increase. Okay, so this is the thing. Okay, this is the basic difference between them. So one thing is that you cannot define the one module definition in other module. Okay, but instead of them, what you can do, you can instantiate one module in the top module. What right now I explained in very details. What are the syntax? In the later video we'll explain. Okay. Okay, so in the next part, I will discuss the module syntax. Okay, thank you.